Howdy, everybody. We're here for Advent to Code Day 15 for the year 2015. Um, as I've said before, we're just trying to solve some problems, see if we can't smarten ourselves up before December when we start again. Um, just kind of running through some algorithms. We'll see what this one does. Hopefully, we can. I mean, at some point, I'm sure we'll find one that I can't solve. But we may I don't know. Maybe I don't. I vaguely recall some of the years, especially the earlier years, being relatively easy. So we'll see. Anyway, love to see your comments. Any thoughts you have on it would be great. So just let me know. Right. I always learn a lot just by seeing what other people are doing and reviewing their code and comparing and contrasting. Eventually, that brings you to a good thing, like a good place, right? Hopefully everyone's gotten better by doing that. So that's kind of the goal here and the hope. So let's just do that. We'll just start with science for hungry people. Today you set out on the task of perfecting your milk dunking cookie recipe. All you have to do is find the right balance of ingredients. Your recipe leaves room for exactly 100 teaspoons of ingredients. You make up a list of the remaining ingredients you could use to finish the recipe, your puzzle input, and their properties per teaspoon. Each of them have a capacity. How well it helps the core. Excuse me. How well it helps the cookie absorb milk. The durability. How well it keeps the cookie intact. The flavor. How tasty it makes it. Texture. How it improves the feel. And calories. How many calories it adds. Okay, so I have a list of ingredients. I kind of actually want to look at it right now. So we have sprinkles. So sprinkles has 2. What is this? How well it helps the cookie absorb milk. So some of these are 0. So capacity, durability, flavor, texture, calories. And you have these different things. So this is our ingredient list. And we have different like attributes for each of them is maybe the way to think about it. You can only measure ingredients in whole teaspoons. Okay, we're doing whole numbers. And you have to be accurate so you can reproduce your results in the future. The total score of a cookie can be found by adding up each of the properties. Negative totals become 0. And then multiplying together everything except calories. For instance, suppose you have these 2 ingredients, butterscotch and cinnamon. Then choosing 44 teaspoons of butterscotch and 56 teaspoons of cinnamon, because those add up to 100, would result in a cookie with the following properties. 44 times -1 plus 56 times 2 is 68. 44 times -2 plus that plus that. Okay, so you're just adding up all the durability or all of the attributes. Multiplying these to get these 4 together, ignoring calories for now, results in a total score of blah, some giant number, which happens to be the best score possible given these ingredients. If any property had produced a negative total, it would have instead become 0, causing the whole score to multiply by 0. So if any of these ever, if any properties had produced a negative total, yeah, so summing these up, it would be 0. And because you're multiplying, it'd be so essentially, if you ever find a 0 in here, it becomes 0, and that score isn't counted. Given the ingredients in your kitchen and their properties, What is the total score of the highest scoring cookie you can make? Hmm. So here's the things to think about. And then we'll start on part 1. There's only 100 teaspoons, and there's only 4 ingredients. Because that's relatively low, it feels like there's a potential for you to just say, oh, I'm going to try all of them. Try all possible like permutations of 100 teaspoons. Anyway, let's maybe move on to part 1, see if we can't solve the actual problem. Yeah, that's what I'm thinking is going through my mind. Like, could we... You only had to do 3 for loops, and then the rest would be the last. So, like, that is like 100 cubed, is still not a lot. Right? Like, this is how many different... We're going to test a million different ones and ask ourselves, of the million different ones, which one produces the highest number? And the reason why this is not a lot, again, like, I think modern calculator or modern computers can just do this really fast. I also, for some reason, the dynamic programming approach is not coming to me for that. Usually when there's a dynamic programming, you could kind of say, like, I mean, I guess what we are going to do is along the lines of like recursive, is like, the idea is if you say like, oh, if I grab 10 of ingredient 1, what's the maximum I can get from the rest? And then I'm going to grab 11 from ingredient 1 and say, what's the maximum I can get from the rest? And then I'm basically going to do that until I find like the max of them all. I mean, that's kind of what's going through my mind. I mean, let's just try it and see if it's not fast, but I presume it will be fine because, again, it's only 100 cubed. And it's not even that. It's like 100 cubed over 3 or whatever. I don't remember the exact number. Okay. So let's start with parsing. So we'll have a struct ingredient with capacity, which is a I size, duration, I size, flavor, I size, texture, I size, calories, I size. We don't calculate calories, right? Yeah. Interesting. Maybe, oh, maybe it's part 2. I was like, what the heck is the calories for? It's probably for part 2. Okay, so let's do a parse on this. Uh, We just split by white space collect. And then we want to return this with 0, 1, 2. So parts 2 dot parse dot unwrap. So is it 2, 4, 6, 8, 10? Oops. Parse dot unwrap. Oh. What does it want me to do here? Probably this. Like that. Right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get capacity, duration, flavor, texture, calories. Again, we aren't using calories. So we want to calculate so we have some kind of FN score. Oh. Like, I don't want to sum up the score. I think I just want to return. Like, this may not be useful. I was thinking of creating a score function that will, but it's really just multiplying all of these and returning the 4 values. I mean, maybe I still do that. So we record return capacity, duration, times, teaspoons, flavor, times, teaspoons, texture, times, teaspoons. Yeah, I don't know how helpful this will be, but we'll use it. Okay, so now I can parse it and I can return like a single score for that flavor. So again, for part 1, yeah, I think we can just do, let's do it in a non-functional way for now. Actually, I guess we could do it functional. Happens to be the best score possible, even if any properties have produced a negative total. it would have instead become 0, causing the whole score to be 0. I mean, I think I'm still going to use an eye size. But the idea is we say like let capacity, duration, flavor, texture. Oh, I don't want to do this yet. I want to have a max value. Return max. And then I'm going to say like for x in 0 to 100. For y in 0 to 100 minus x. And for z in so these are our 4 values, w, x, y, and z. I guess I need to parse it. So let's do that. And then what do we do? So this will tell us how much we want of each ingredient. So this will be ooh, do I want to use? I actually think I want to use this, and then I can use because I can do like I want this score instead of returning this to return an ingredient. Because then I can try and do math on it like this. Or it will at least be why doesn't it like this? Oh, I don't have calories. We aren't calculating. I guess I so okay. So we can say like let x score equal to ingredients 0 dot score x like that. And then we do y and z and w. So this is 1 2, 3. I mean, this is really ugly because it's like a wacky for loop. I kind of want to combine these values together. So we can say like, let capacity equal x dot score dot x score dot capacity we add them together. Plus y score dot capacity plus z score dot capacity plus w score dot capacity. So we change these all to durability. What do we call it? Duration. That's not what it was, so I'll fix that in a second. This should be durability. So now here, the next one is flavor. And then texture. Okay. I'm a little worried these numbers are going to be really large. And that may be why it's saying if any of them are 0, it produces a 0. Just so like I don't overflow. So I can say like if texture equals 0 or capacity equals 0 or durability equals 0 or flavor equals 0. Continue. Like we can just say, oh, that didn't work. Otherwise, we want to say max equals max dot max of capacity times durability times flavor times texture. First time every time? I mean, that looks ugly right now, but does it even work? No. Parse int error, invalid digit. Line 17. 0, 1, 2. Oh, it's got commas. That's funny. Like that. Second time every time? I mean, okay. That is not. It is too high. Okay. But that number is not huge. 1, 2, 3, 100,000 million. I'm inclined to think I don't need this one. So let's just make sure I'm calculating this right. I have some number of teaspoons for X, Y, and Z, and W. What happens if it's like, well, it's like, what if I use 100 of these? Oh, this would be 0. This would be 0. This would be 0. I'd still calculate it once. Is that right? So, like, if I have a for loop from 0.0, does it run for 0? Sorry, there was no. Okay. Something's wrong with my Copilot chat. I'm sure it's happened to you as well, right? Like, or maybe not. Maybe it's just me. But I can ask Gemini. Does this apply to Rust as well? Yes, this applies to Rust. Oh, no, it says this one will not run at all. So I need to do equals here. That doesn't change the answer, though. But that probably was a bug. So let's just make sure I sum the capacities, the durability, the flavor, and the texture on their own, and then multiply them together. Yeah, so like this capacities, the total capacity is equal to the X's capacity plus the Y's plus the Z's plus the W's. I'm doing this the wrong way, huh? No, oh no, I'm not. The X score is for ingredient 0. So if X is, say it's 50, I want to apply that to all of a single ingredient. Right? So I say, give me the score of this, and I'm going to do this. I'm going to multiply them all together and get the score for that ingredient. And then I'm going to do that for the Y as well. Oh, let's see. Does this work? Yes, it does, because I need to have exactly 100. And presumably W fills up that void, right? Like if this is 0, 0, 0, W would be 100. Not seeing an error. Capacity 2, durability 4, flavor 6, texture 8, calories 10. The order doesn't matter, at least for these first four, because you do like the same, as long as you're doing the same calculations, you could potentially do them however you want. I have the right inputs. Sprinkles, butterscotch chocolate candy, 0, -1, 0, 5, 8, 2, 0, -2, 0, 3. Yeah, okay. I've had some problems with my thing, but I think I fixed them with my account. I think I fixed them. So I have the right input, I think. Let's see. 44 times -1. I mean, I guess I could double check to make sure I have the ingredients correctly. Oh, I need to implement debug for this too. Oh. -2, 0, -3, 0, 5, -3, 0, 3. Yeah, that looks like I have them. You guys are probably yelling at the screen that it's obvious, but I'm not seeing it. The struggle is real, right? Sometimes you think sometimes you watch YouTube videos and you're like, oh, am I the only one that has problems sometimes? But no. If you've done it long enough, you understand everyone has it. Okay, so let's just step through it again. I pick some value for X and get its scores for ingredient 0. I have the Y and I do ingredients for that. Then I have the Z and I do ingredients for that. And the W is the rest of what's left over. And I do ingredients for that. So then I get each of their capacities and add them together. Each of their durabilities, each of their flavors, and each of their textures, and add them together. And then if any of them are 0, I skip it. I don't think this is necessary. Like, I'm fairly sure this won't change it. It might, though, for very large values, but maybe we just don't worry about it now. So what's the thing that I could be missing? So I could try it just with 2 for now. So what does that look like? I want to do, I guess it's just, I want to keep this stuff around, I think. There's probably a more elegant way to do this. Like that. Hmm? Oh. These ones, because there's now only two. Something is definitely wrong. That number is absurdly large, right? So I have 100 teaspoons. I mean, I can just print. Maybe I print these as well. So we do Z score, W score. I mean, it's going to be a big wall of text, but negative 100, negative 200, 600, 300, 800. And at 0, you have 0, 0, 0, 0, 0. 2, 3, negative 2, negative 1, 3. I mean, that feels negative 99, negative 198, 594. Why is that wrong? It's totally incrementing up. Like negative 100 times 0. Oh, I could be getting negative values. That's what I'm doing wrong. If this is negative, it's 0. So my check, I do actually need to check. It should be like, sorry, it's late. So can I blame it on being late? Like it feels like that's what I want to do. 62842. Yep, there you go. Okay. So that was my issue. So let's go back to this. And DC. Put this back here. And get rid of these. And that should give us a better answer. It looks different, presumably better. There we go. Okay, good. So what was my flaw in my logic here? I actually had this if check, but I was only checking if they were equal to 0, but I was missing the negative part, right? It said in here that if a property had produced a negative total, it would instead become 0. Or if any properties had produced, causing the whole score to multiply by 0, would result in a cookie with the following properties. Yeah. Negative totals become 0. So that's the part that I was kind of missing. I thought I kind of did it here, but I had missed it. Can I blame it on my lateness or on how late it is? I'll let you decide. But okay, that we'll refine this a little bit. We'll see what happens in part 2. Presumably, it has to do with the calories. So let's go look. Part 2. Your cookie recipe becomes wildly popular. Someone asks if you can make another recipe that has exactly 500 calories per cookie. Keep the rest of your award-winning process the same. For example, given the ingredients above, if you'd said selected 40 and 60, you would have had 500 calories. So I just need to calculate the calories, and I only include the max if the calories are 500. Calories are always a positive number. So I think to solve it, I can literally copy and paste. And then just check if the calories are 500. So we can say let calories equal x score dot calories plus y score dot calories plus z score dot calories plus w score dot calories calorus or calories not equal 500. Oh, it's an eye size. A few days ago, I was always changing it, not knowing what it was going to be ahead, and now I'm not changing it. And I'm missing it. I presume part ones and twos will often return the same value. Okay, so I don't change anything. I just have this additional check that says calories do not equal 500. If I ever find one of those, I continue. So I only include ones that equal 500. That seems right. Oh, assuming I've calculated calories too. I think I did because I was doing it up here, right? Yeah. Da da da. 15. There you go. 15. We did it. I wonder. Okay, so I don't think this was this hard. Again, these are, like I said, these are finishing in microseconds, right? There's probably some optimizations you can make. I'm suspect of it being a dynamic programming problem, other than like this being the dynamic programming part, where you could potentially like solve this recursively. It may actually make the code look cleaner if you do it recursively, ironically. And it would be more generally solvable. I guess I don't know what everyone's solution looked like. If you have exactly 4 ingredients, like this loop works. Um, yeah, but if you had like 5 or 6 or 7 or 3 or 1, like you have to change the 4 loops. Otherwise, the 2 parts are the same except for calculating the calories and then this if block. So you could potentially also merge the code and then just have a continue function that you pass. So we could potentially do that. It could actually just be this one thing right here, right? So you could actually say check calories and then do an and or you know, or check calories is true and calories is not 500. That would probably be the most simple way to do it. Um, yeah, we could try and do that. The recursive approach. How is it bubbling up in the recursive approach? Because like what's happening in this for loop is I'm kind of tracking the values. Like I have the X score, the Y score, the Z score, and then the W score. I guess I could track the previous scores and then sum each of them up. It's probably going to look cleaner too. So let's just try it. We'll say like fn calc scores. So I want to have what's left. So remaining is going to be an I size. And I want to have the ingredients that are left, which is going to be a list of ingredients. And then I want to have like the previous scores. Which are also a list of ingredients. So that's these ones that I've seen. And I'm going to give you an I size. So we'll have some sentinel case, but the most of the cases will be like 4x in 0. Remaining. We will say we'll call it recursively. We'll say calc scores. Remaining minus x. And then we'll do ingredients 1. And we need to know my score at this time. I think I can just do like this. Scores.push. Score. Doesn't it like here? Oh, it's not a vector anymore. Ingredient doesn't have a clone. Okay. Expected 3 arguments, found 2. Huh? What? Remaining minus x. Ingredients. Can I still blame it on being tired? Was that this video? Expected 3 arguments, found 2. Remaining minus x. Hmm? Boy, I'm really missing something. So I call calc scores. Remaining minus x. Ingredients. Scores. Expected one of dot operator found. Oh, how does this work here? Is it like that? Okay, so now here we say, so that's the normal case, and so now we say if ingredients.len equals 1, then we can actually return the value. Here's where we want to actually do the calculations right here. So it's going to be like let capacity equal oh, we still want to do this. So let capacity equal scores.map like that. Oh, I need iter. And then we just do that for the other 4. Which is durability, texture, and flavor. So we can have calories bool as well. And so then we have this check right here. We'll call it check calories. because we also want to do this for calories. Or check calories and calories. Something like that. Okay, so this is a weird recursion, but like hopefully it makes sense what I'm doing. Like the idea is if I don't know how many ingredients I'm going to have, doing this for loop is a little weird. So I'm going to kind of do the for loop, but with recursion, right? So I'm going to have some set of remaining teaspoons, some set of ingredients, some set of previous scores, and then whether or not I want to check the calories. I think this will return the same thing, right? Because I can do the same stuff. Oh, otherwise, return cap times durability times texture times flavor. Yeah, make sure we have that. Like when I'm at the last ingredient, I want to do this. Okay, I think this will work. So let's just try it. So it's going to be calc scores. We're going to start with 100. An empty vec. And false. Do this as well. I am cloning in it, so it might be slower. We'll see. 21367. So it is the same number, and you can see it is actually slower, and it's almost certainly because of the cloning. It's the scores that I'm actually cloning. The ingredients doesn't change. Well, I could make this mute, I think, right? And then do scores.push here. And then after I've gotten the scores, I can do scores dot. Wait, what's it like here? Oh, let's make this an actual vec. Remove the last element. Pinned. Yeah, I think this is right. Like this. Oops. What happened there? That speed it up at all? Yikes. It does not appear so. Oh, it's that. I mean, we are faster, but it is still clearly slower. Uh, so I actually don't know if it helps. It looks cleaner than the other way, so I'm inclined to keep it. Yeah. It's not, again, it's not the most optimal. I'm curious if, yeah, I'd be very curious if you have a more optimal solution. Uh, like that. It's like one order of magnitude slower, but it's not bad, right? I'm still in the milliseconds. Like it finishes almost immediately once it's compiled. And I feel like it's more readable, so I'm inclined to keep it like this. The other thing, you could still do the for loop, and what might make it more readable is if you had like a struct that was like a running total of the ingredients. Like if you had a count, like if you had an array of ingredients and you were tracking them, and then you could do the calculations. The part that looked ugly to me was all the adding and subtracting and stuff like that. And maybe it's not a big deal. I'll submit this way. If you want, you can go look at the for loop and see what it looks like, so you can just get an idea. Again, it's late, so there's a potential for me to have like missed something. Uh, and what I mean by that is some cleaner, more readable way to do this than like doing this recursively. And I know I've said this before, but one of the advantages of doing it this way is I don't have to have a for loop per ingredient if the ingredient list is different. So we've had issues like that before, and I'll just say that I'm inclined to say solve the problem for the problem set that you're given. Like if your input is 4 and you say to yourself, "Oh, 4 means I can do it this way." It's probably okay to solve it with 4. Sometimes you'll get people that will say, "Oh, that's not a generalized solution to the problem." But I think there's a lot of times where there is just not a great generalized solution to the problem. And so you have to like look at your plan, you look at what your input is and make decisions on solving it based on the input. That's always kind of the case, right? Even if you do like competitive stuff, like I don't, like you've probably seen in Leak Code, or if you've done any competitive programming or watched any competitive, they always give you bounds, right? And the reason why is because that allows you to choose algorithms based on those bounds, right? The solution to a problem where n equals 10 is much different than n equals a million. And your ability to, like, they kind of want to test your ability to say, oh, well, if it's small, I can use this simpler algorithm that I can type out much faster than if it's large and I need to like rewrite from memory, like the Floyd Marshall algorithm. I'm probably saying that wrong. Floyd Marshall, is it? I think it's Floyd Marshall algorithm. We've talked about it in previous videos. Anyway, or Dijkstra, right? Say, oh, doing, do I want to try and redo Dijkstra, right? So as opposed to just saying try all the permutations. So Anyway, there you go. Day 15 in the bag. Yeah, I think this code, it becomes pretty readable, at least in my mind, when we have like this calc scores. So send me yours though. I'd love to see what you think about how you solved it. Maybe you found some more readable ways to do this, and that would be great. I'd love to see it. But with that, I think I will say have a good day, and we'll see you next time.